All right, this is Chapter 7, Section 4, the Grandmaster video. We're going to continue with perpendicular lines here. So we want to determine the equation of the line that is perpendicular to 3x minus 6y plus 18 equals 0. But we want our line to pass through the point 4, 1. Okay? So let's take our line here, and right now it's written in general form, which isn't particularly useful. So let's rewrite this so we can determine the slope. So I'm just going to isolate y. So I get 3x plus 18, and I'm going to add 6y to both sides. So there we go. And now I'm going to divide by 6 to isolate y. And this reduces, so I get 1/2 x. And positive 18 over 6 gives me positive 3, so plus 3. And then I get y. Okay, so this is actually the equation of the original line. Okay, but what I'm looking for is the slope, because I need to use this slope to get the slope of my line. Okay, our line has to pass through 4, 1. Okay, well, if this line has a slope of positive 1/2, the slope of our line has to be the negative reciprocal of this. Okay, so our equation is y minus 1 equals, and I'm just going to leave a blank space for the slope here. I'm just going to get this information. So this is x minus 4. So this is our line, but what slope goes here? Okay, so if I were to copy this 1/2 over here, that would mean that my lines were parallel. The slopes are the same, but they're perpendicular, which means that the slope is negative 2 over 1, or just negative 2. Okay, so in fact, that's all we need to do. It doesn't ask us to do anything. That's the equation of our line in slope point form. And just to reiterate now, the relationship between slopes of lines that are perpendicular. Okay, if I call this, let's call this m, right? Mx plus b. And because this is the slope of the line perpendicular, I'm going to call this m perpendicular. And there's a little symbol. It's like an upside down capital T. Okay, so these are related by the following. M perpendicular is just the negative reciprocal of m. Or another way of saying it is, if I multiply both sides by m for this equation, I'll write it over here, that means m times m perpendicular is negative 1. So this equation in particular is useful if you want to test to see whether or not lines are perpendicular. Just multiply the two slopes and ask yourself, do I get negative 1? We can also check our work. What is negative 2 times positive 1/2? That would give me negative 1. So I know that these lines are perpendicular. All right. Before I move on to the next part, I'm just going to graph our lines here. Why not? Okay. So let's graph the original line. Okay. Now I did the work here. I put it in slope-intercept form. So it has a y-intercept of 3 and a slope of 1/2. Okay, so I'm going to get that line in here. So that looks like that. There we go. Okay. But our line has to pass through 4, 1. So that's right here. And our line has a slope of negative 2, or negative 2 over 1. So just get a few dots in here. Why not? Okay. But notice when I draw this line, look how it intersects the blue line. Okay. This angle is 90 degrees. Okay. So these two lines are perpendicular. So next, it wants us to express in slope-intercept form and verify that the y-intercept is correct. So that's this line, the line that we just created. Okay, so all we need to do is take my answer from here, which is in slope point form, and express it in slope-intercept form, which just means I got to solve for y. So I've got y minus 1 equals, and I'm just going to expand this bracketed set. So this gives me negative 2x plus 8. Negative times negative is positive. And now I'm just going to add 1 to both sides. So this gives me y equals negative 2x plus 9. So that's the equation of our line in slope-intercept form. Our slope is still the same, it's negative 2, but look at the y-intercept now. Okay, did our line cross at 9? Yes, it did. Right there. So we know we did it right. All right. Moving on to the critical thinking problems. The lines 6x minus ny plus 7 equals 0 and x plus 2y minus 10 equals 0 are perpendicular. So here we have two lines. We're told already that they are perpendicular, and we simply want to determine what is n. So n is just, well, in general form, that would just, I guess that would be the b. Okay, we're trying to determine what number does n have to be such that these lines are perpendicular. Okay, so let's determine the slopes of these lines. Okay, so I'm just going to solve for y. So I'm going to get 6x plus 7. I'm going to add ny to both sides. Remember, n is just a number. It could be 3, it could be 5, I don't know. So I'm going to treat it like any number. I just don't know what it is. So I'm just solving for y. So these n's cancel. So I get y equals 6 over n. Well, the best I can do is 6 over n x plus 7 over n. Okay, so that's the equation of the first line. Now it has obviously it has an unknown y-intercept because I don't know what n is, and it has an unknown slope. But I don't care about this y-intercept. I just care about the slope. Okay, because I'm going to have to use that along with the slope in the next one. This line is complete. We have all the information we need. Let's just figure out the slope. So this gives me 2y equals negative x plus 10. And then I'll divide everything by 2. So this cancels out, and I get y equals, and I get negative 1/2 x plus 5. Okay? Now, I don't care that the y-intercept is 5. All I need is the slope. Okay? So we are told already that these lines are perpendicular. So we can use the fact that if that's true, if I multiply the slopes together, I must get negative 1. I can't get anything else. If I got some other number, it means they're not perpendicular. So we're going to create an equation. So this gives me 6 over n times negative 1/2. I'm going to put the negative 1 in the numerator. That has to be negative 1. Okay? So now I have an equation. I'm just going to solve for n. So in the numerator, I get negative 6. And in the denominator, I get 2n. And that is equal to negative 1. All right, now I'm running out of room here, so I'm just going to shift my work up here. Okay. I'm going to multiply both sides of this equation by 2n. That's what I'm going to do. So they're going to cancel. So I end up with, I'll go back to blue, I get negative 6 equals, and negative 1 times 2n is just negative 2n. Well, that's easy to fix. Let's just divide by negative 2 now. Okay, so that cancels. So I'm left with n, and that is equal to positive 3. So there we go. N must be 3 in order for these lines to be perpendicular. And we can check that now. Because if n was 3, what is 6 over 3? Well, that gives us 2. And we know that a line with a slope of 2 is perpendicular to a line with a slope of negative 1/2. So I know that this is right. All right, lastly, we have two line segments, and we call them AB and CD. Segment AB contains the following points, labeled A and B, and we're given coordinates. So in other words, we just have a line that is connected by these 2 points. But we have another line segment that is connected by points C and D, and here are the coordinates. Now, without a graph, I want to determine if these line segments are perpendicular to each other. So really all we need to do is, let's find the slope of the line connecting points A and B, and then we'll find the slope of the line connecting points C and D. And then we'll just do a test. Okay? Are they perpendicular to each other? So let's find the slope of AB. Let's do that. So we're just finding the slope between 2 points. So y1 minus y2, etc. So I get 8 minus 13 over negative 12 minus negative 5, which gives me negative 5. Okay, and this here, negative 12 plus 5, that's just negative 7. So I end up with positive 5 over 7. So that's the slope of the line for line segment AB. Now let's do the same for CD. So slope of CD, so let's use the other points. We get 9 minus 2 divided by 15 minus 20, which gives 7 over negative 5, which is just the same as negative 7/5. There. I can actually tell just by looking at them that these line segments are perpendicular, okay, because you can see they are negative reciprocals of each other. But if that's not good enough for you, or you're just bored, let's multiply them together just for fun. And I'll put the negative up here. Okay. Well, 5 over 5 becomes 1 over 1. And negative 7 over 7 becomes negative 1 over 1. So yes, I get negative 1. That's just to further prove the point that yes, these lines are perpendicular. Line segments. So I'll just put yes. All right, there we go.